Hello everyone, welcome to another video of electrodynamics where we'll be solving questions from Griffith. Alright, yeah. So here, see, this is a diagram which is showing relations between a charge density rho, potential V, and electric, electric field E. Okay, it's taken from the book Griffith, and see if you can remember this diagram, you can remember a lot of things about potential, charge density, and electric field, the relations and all. So if you see the first this one, potential is minus of E dot dl, isn't it? We know this one. Like line integral of electric field is your potential negative. Okay. Where did this come from? This is like E is equal to minus del V, isn't it? Hmm. So yeah, from this it came. Hmm. So now if you see, yeah, this one is also written here. See, E is equal to minus del V. Gradient of potential is your electric field. Now this is the relation between potential and electric field. Now potential and rho, that is charge density, is what? Now this is Poisson's equation. Rho square V is del square V is equal to minus rho by epsilon naught. This is a what? Poisson's equation. This is a Poisson's equation, isn't it? Rho square V, sorry, del square V is equal to minus rho by epsilon naught, and V is equal to what? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught rho by r dr dv. So rho by r dv. All right. So this is a what? This is how it came, because the original formula of potential is 1 by 4 pi epsilon naught q by r. So q we know is rho dv. So I just put it there. So 1 by 4 pi epsilon naught rho dv by r, as r is also included kind of in dv, so didn't take r out. All right. Yeah. So this is these are the relation between potential and charge density rho. Now what about rho and E? See, uh, again del dot E is equal to rho by epsilon naught. We know it, right? From this one only, if you put minus del V here in place of E, we are getting your Poisson's equation, that is minus del square V is equal to rho by epsilon naught. That is rho del square V is equal to minus rho by epsilon naught. Now what about this one? This is your electrostatic field. Electromagnetic field, that is E 0. This is, oh yeah, this is for also for electrostatic field. For electrostatic field, curl of E is equal to 0. All right. Now what? But for other one, electrodynamic or electromagnetic field, del cross E is equal to minus del B by del T. All right. That is the other one. This is for electrostatic. Okay. Now this relation again coming from which formula? This is, we know the original formula, 1 by 4 pi epsilon naught q by r square. Q is rho dv. Hmm. Rho dv by r square. That's it. Okay. See, rho dv by r square, and r cab. R cab is the direction of electric field. All right. So these are the relations, correlations between electric field, charge density, and potential. Let's jump into questions. Question number problem 2.31. Three charges are situated at the corners of a square as shown in the figure, and how much work is done to bring in another charge plus q from far away and place it in the fourth corner. So three charges are already there, minus q plus q minus q, a. So how much work is done, how much work does it take to bring in another charge plus q from far away and place it in the fourth corner? Okay, far away and place it in the fourth corner. So how will we do it? Think about it first. Let's think about it. Three charges are there already. So work must be done in order to bring in another charge. Right? So what is the work done? How can we solve it? Charges are there. So if we can calculate the potential, Then we can calculate the Warden. Warden is charge into potential, isn't it? So let's find the potential first. Potential is 1 by 4 pi epsilon naught. For example, for a system of charges, that is summation of Ui by Rij. Okay, yeah, because distances are also there, different distances are also there. Okay, so this is distance A, this is the distance root 2A. So we are bringing the charge here at this corner. That means we have to calculate the distances up to this point. That are the Rij's. Okay, so 1 by 4 pi epsilon naught. First of all is minus q by a plus plus q by root 2a minus q by a. Isn't that right? Because this one is also the minus q by distance a plus q by root 2a minus q by a. Alright. So q comes out q by 4 pi epsilon naught. Okay. Minus 1. Okay. A also comes out. Minus 1 plus 1 by root 2 minus 1. So it becomes q by 4 pi epsilon naught a minus 2 plus 1 by root 2 minus 2 plus 1 by root 2. So this is a what? This is only a potential. So work done will be how much? Work done is your this one q into potential, q into q by 4 pi epsilon this one. So let's put it there. So w is equal to q into q by 4 pi epsilon naught minus 2 plus 1 by root 2. Isn't that right? Okay. So q square by 4 pi epsilon naught a, sorry, a, I missed a minus 2 plus 1 by root 2. Okay, so this is a warden. Okay, is that clear? This is the warden to bring in the fourth charge to the square. What we did, because there is a system of charges, because there is a system of charges, we have to first calculate. We have to first calculate what? We have to first calculate potential of it, of the system. Potential of the system. After that, we will calculate warden. Is that all right? Yeah. Okay. Okay. What is the next question in it? How much work does it take to assemble the whole configuration of four charges? Okay. How much work does it take to assemble the whole configuration of four charges? How much work? How can we do that? How much work does it take to assemble the whole configuration of four charges? Think about it a bit. So I think we have to calculate the work done for each charge, isn't it? Assemble the whole set of charges. See, okay. For that, we need to assume, like, think a bit. We have to think a bit. How? We have to think, assemble the whole configuration of voucher. That means, for example, that means it's saying in the beginning there was no charges. There were no charges. Okay. So assemble means what? We are assembling some people. That means in the beginning there is no one. In the beginning there is no one. There must be someone who will start the group. So there should always be a first person who will start the group. Alright. So exactly here we are assembling four charges. That means there is no. The thing is, at the beginning there is no charge. So we have to get one charge first, isn't it? So that is were done by the first charge. isn't it? Warden on the warden to get the first charge. What should be the warden to get the first charge? Can you tell me? Okay, I will draw the diagram. There is no charge right now. Warden. What is the warden to get the first charge in this setup? There are no charges right now. I will try to get Q here. So what will happen? See, there are no charges, so I can simply put this Q here. As there are no people, simply someone can come here without any obstruction, without any quarrel with anybody. Like I want to sit there, I want to sit there. No, he can just come here, right? So warden is zero. Okay, to assemble the first charge or to get the first, whatever you can write as what. There are no other charges there at that moment. There are no other charges at that moment. All right. Yeah. Now, W2. Okay. W2 is what? This is Q plus Q. This is minus Q. Right? Minus Q. Minus Q will take. So what is the charge? What for that? 1 by 4 pi epsilon naught. What is the charge that is there? Q. What charge we are bringing? Minus Q divided by what is the distance between them? A. Okay. This is the formula. Na? Q1 W is K Q1 Q2 by distance. Okay. Don't confuse between these formulas. Okay. 1 by 4 pi epsilon naught minus Q square by A. Okay. Yeah. All right. Now W3. I'm bringing another charge now. I'm bringing third charge. Q3, that is your simply plus Q. Okay. Now this plus Q. Okay. How will we? I'm plus Q bringing here. So this plus Q is at a distance of. We have to calculate Warden for both in with respect to both the charges at a distance of root 2a from this charge at a distance of a from this charge. So W3, tell me, W3 will be 1 by 4 pi epsilon naught Warden between this one, these two. Q into minus Q by what is the distance? A plus Q into Q by what is the distance? Root 2a. Is that clear? So this will be 1 by 4 pi epsilon naught minus Q square by A plus Q square by root 2a. If I take Q square by A common, Q square by 4 pi epsilon naught A minus 1 by, sorry, minus 1 plus 1 by root 2. Is that right? Okay. And what about W4? W4 we just calculated. W4 we just calculated in the previous case. Isn't that right? This one is the W4. Okay. Okay. Is that clear? So what is the question actually? We have to find the question is what done to assemble whole configuration. So we have to just add them all. Okay. We just have to add them all. W total. Whatever you got, W1 plus W2, W3 plus W2. Just add them. Okay. If you add them, you will get the answer. Alright. The answer will be, I'm telling you, answer is 1 by 4 pi epsilon naught 2 q square by a minus 2 plus 1 by root 2. Okay. Yeah, that was a very good question. Really. Really, that was a good question. Okay, next question. Next problem 2.32. Two positive point charges Q and a Q2 QB are at a rest held together by a massless string of length A. This is your QA. This is your QB. They are at a rest held together by a massless string of length A. Not spring, okay? It's string. It's not spring. Don't draw this. Now the string is cut. Now the string is cut. And the particles fly off in opposite directions. QA in this direction, QB in this direction. Okay. How fast is each one going when they are far apart? How fast is each one going when they are far apart? Okay, let's think about it a bit. It's a bit two positive point charges Q and QB are at rest held together by massless string of length A. Now the string is cut. The particles fly off in opposite directions. How fast is each one going when they are far apart? Let's try a bit. How do I approach this question? This is Q A QB. Yeah, now the string is cut. That means the energy stored at this moment. This is a potential energy. When they're moving, then gone. That converts into kinetic energy. I think that's we have to calculate. I think so. Let's think a bit. No, this is not the way. Okay, see. Here your just a moment. Give me a minute. Till then, you keep trying. Potential energy of water is by pi epsilon naught QA into QB by A. So when they're moving fast like this, kinetic energy of this one is half ma v a square. Suppose kinetic energy B is half mv vb square. So this potential energy will be equal to total of kinetic energy. After this, how to solve it? I have no idea. When I am unable to solve it, you please try and If you can solve it, please let me know in the comments. Right? Yeah, I'm unable to solve it. Yeah. Next question is find the energy of a uniform uniform charged spherical cell. Okay, total charge Q and radius R. Uniformly charged spherical cell. Total charge Q, radius R. Okay, how to solve this question? Find the total energy. Energy we have to find. Okay, so energy is how much? If you know, is equal to half integration of sigma V into dA. That is area sigma dA into V. The potential into we know Q into V is your work done, right? So Q is actually what here? Sigma d, that is V. And just integration and half, that's it. Okay. So potential, what is the potential of the surface? Do you know potential of the surface? Charge is there, radius is R. Simple potential will be 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q by R. Okay. 1 by 4 pi epsilon naught Q by R. So if you put it here, W is equal to half rho 1 by 4 pi epsilon naught Q by R into into dA, right? Yeah, dA. So let's take everything these things out. So 1 by 8 epsilon, not 8 by epsilon because 1 by 2 was there. Sigma QR. This is no sigma we can take sigma dA. All right, sigma dA. So that will be the answer only, I think. Because sigma dA integration is how much? This is your Q, isn't it? Sigma dA is Q. I just wrote here sigma dA is Q, so I can put it here. Q by 8 pi epsilon naught R into Q, that is Q square by 8 pi epsilon naught. Is that right? Is that correct? Okay, that is the answer. Okay, that is the answer. Okay, next question. Find the energy. Find the energy stored in a uniformly charged solid sphere of radius r and charge q. Do it in three different ways. Energy stored in a uniformly charged solid sphere of radius r. Do it in three different ways. Okay. Find first. You find the potential. Then don't forget to integrate it over all space. Take a spherical volume of radius A. What happens is A tends to infinity. Okay, so this is a very good question. Okay, find the potential and all. Okay, so how do we do it? Find the energy stored. Okay, so let's first of all the formula is what? Epsilon by 2 E square dV. Okay, that is the formula. This one is also a formula here. dV, this is a volume element E square. We know E is equal to how much? The charge is Q. Saying the charge is Q, radius is R. So obviously E is how much? Second. Okay, wait. No, not this one. Hmm, okay, we'll do the other way. W is equal to half rho v dv. This way we'll do dv. This is a volume element eta of item. Okay, because it's saying to find potential to use the potential. So the potential in this problem was actually you have to have the book to solve this question. Potential in that problem was rho by 2 epsilon naught r square minus r square by 3. We have to use this potential in order to get it. Okay, so if you see, we can write it as 1 by 4 pi epsilon naught q by 2 r 3 minus r square by 3 r square. This was also the potential that was found in that question. So we have to use this one here in this v. So w is equal to what? Half rho v dv. So half rho into potential is how much? 1 by 4 pi epsilon naught q by 2 r 3 minus r square by r square. And dv is a what? Dv I can write 4 pi r square dr, isn't it? So you take rho out, 1 by 4 pi epsilon out, whatever things that are unnecessary just out to integration 0 to r, because all over space, right? Yeah, all over like the sphere by r square dr. 4 pi can be out. So if we do this a bit, rho q by 4r epsilon naught 0 to r 3 r square dr minus 0 to r r fourth by r square dr. Is that alright? Okay. So hmm, so rho q by 4r epsilon naught rq is 0 to r minus r5 by 5r square 0 to r. Okay. So rho q by 4 epsilon naught r mistake, right? No. This is rq minus r5 rq by 5. Isn't that right? So rho q by 4 epsilon naught r 4 rq by 5. This is a what? This is a Warden. Um, 4 were cancelled. RQ, this becomes R square. So rho Q R square by 5 epsilon. This is the answer for it. But otherwise, I can, yeah, this answer. This is the answer. Otherwise, see, this rho, I can write it as Q by V. Okay, Q by, what is the volume of the sphere? 4 by 3 pi r cube. So rho, I can write Q by 4 by 3 pi r cube into q r square by 5 epsilon naught. That q square r square 3 goes up. 4 pi r cube 5 epsilon. I can arrange it a bit. If you see, you will get it 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught 3 by 5 q square. This becomes like r q square by r. This is a water. Okay, is that all right? Okay, 3 by 5 q square by r. Yeah, we got this answer, so don't need to do it three different ways now. Okay, we got the answer anyway. Okay, next question. Let's move to the next question. Problem 2.36. Consider a concentric spherical cell of radius A and B. Suppose the inner one carries suppose the inner one carries a charge q and the outer one carries a charge minus q. Both of them uniformly distributed over the surface. Calculate the energy of this configuration using equation 2.5. Okay. See, first of all, the charge distribution for this one inner one will be, this is your radius r, this is your radius b. What will be the charge distribution for the inner surface? Can you tell me? Inner one will be simply minus qa by 4 pi a square minus qb, that is charge on b, that is 4 pi b square. Okay. Hmm. Total will be what? Like the whole one? qa plus qb by 4 pi r square. Okay. Hmm. This it's not the way to do it. Because what will I do with this charge density? So let me do one thing. W is equal to epsilon by 2 e square dv. E is the electric field. Okay, for electric field at this point, any like at the center point would be how much electric field is equal to 1 by 4 pi epsilon naught q by r square. The distance being r, less than r less than b. So I'll just put it here. So epsilon by 2, epsilon by 2 q by 4 pi epsilon whole square. 1 by r fourth into dv. I can write 4 pi r square dr. Okay, so this becomes epsilon by 2 q square by 16 pi square epsilon naught square 1 by r fourth 4 pi r square dr. This becomes r square. This 4 pi goes out, so 4 pi epsilon naught q square by 32 pi square epsilon naught square. And this becomes dr by r square, that is minus 1 by r. Minus 1, what is the unit? Sorry, what is the limit? A to b, isn't it? Because the electric field is between A to B. So this cancels it out 8 pi epsilon naught. So q square by 8 pi epsilon naught minus a 1 by b minus minus plus a 1 by a. So that becomes q square by 8 epsilon naught 1 by a minus 1 by b. Is that alright? Is that alright? Okay. Now, another way we can solve it also. After using this one, also using another one. So another way we can solve it like For example, W1 charge for the charge 1, that is 1 by 4, 8 epsilon naught q square by A. W2 will be 1 by 8 epsilon naught 8 by epsilon naught q square by B. Okay, and electric field is how much? Same way, it's the same way actually. Mm, electric field is 1 by 4 pi epsilon naught q by r square r cap. A2 is 1 by 4 pi epsilon naught minus q by r square r cap. Isn't that right? Okay, this far greater than B, this far greater than A. So if I multiply E1 into E2, 1 by 4 pi epsilon naught whole square and minus q square by r4. Okay, so this is for r greater than B. So if you see actually E1 dot E2 into dV, that is minus 1 by 4 pi epsilon naught whole square. Okay, q square, and this is 1 by r4 4 pi r square dV. Okay, and this will be what? B to infinity because it's outside. Okay, alright. So if you calculate this minus q square by 4 pi epsilon whole square r square. Okay, and this will follow the same pattern, same all everything will go on. Okay, and W total will be what? W total will be W1 plus W2 plus epsilon naught E1 E2 dV. So this is another way to solve this question. You will get the same answer q by 8 epsilon naught. Okay, q square by 8 epsilon naught. Okay, 1 by A minus 1 by B. Okay, this will you will get this one. Is that all right? Is that all right? Yeah, this is the answer for it. Okay, this is the way to solve this question. It's very lengthy and derivation kind of questions which we'll be only able to solve when we have that much practice in all those things. Okay, it's not like you just came here and you can solve everything. All right. Find the interaction energy for 2 point charges distance a apart. Okay, can you do this one? This one is a homework. Try this question. Okay, think about it. All right. Interaction energy you have to find out. That is, we just did some similar type of question in the previous question. So this one you try. Okay. Okay then. Thank you very much for watching. Okay. See you in the next class.